You know, we're all sort of used to this idea in the AI landscape that intelligence, well, it costs billions of dollars and needs its own power plant.
That's been the orthodoxy, yeah. The scaling laws.
The rule has been simple. If you want a smarter model, you just build a bigger model.
More parameters, more GPUs, more data. It's a brute force method that's worked for years.
But I've got a research paper here from NVIDIA that really challenges that whole idea. It's about a new family of models called Nemotron-Cascade.
And they're small.
They're tiny. We're talking 8 and 14 billion parameters, but they're apparently outperforming these giants with over 600 billion parameters. So our mission for this deep dive is to figure out how. How does the student model end up beating its teacher?
It all comes down to how the model learns, not, just how much data it eats. The paper introduces this strategy they call cascaded reinforcement learning.
Which sounds a lot more structured than the usual method.
Oh, absolutely. Usually you're just throwing everything, poetry, Python code, math, into one giant messy soup.
Yeah, and hoping for the best.
Exactly. And that noise makes it hard for the model to really generalize well. NVIDIA's Cascade approach is sequential. It's a pipeline.
Like a curriculum.
Precisely. They train it strictly in order. First comes instruction following, then math, then coding, and finally software engineering.
Okay, I see the logic, but usually when you teach a network like that, you hit a wall called catastrophic forgetting.
Where it forgets the old stuff.
Right. If you make it code for a month straight, does it forget how to be a helpful assistant? Did that happen here?
And that is the most surprising thing in this paper. Not only did it not happen, they found the opposite. They found a positive transfer.
A positive transfer.
The very first stage, the alignment with human feedback, or RLHF, it actually made the model better at math and coding later on.
Wait, hold on. RLHF is usually just about making the model polite, not saying harmful things. How does learning manners help you solve an equation?
It's not about the politeness. It's about the conciseness. The alignment training basically taught the model to stop rambling.
It reduced verbosity?
Yes. By forcing the model to be clear and token efficient, it decluttered its whole thinking process. And that clarity translated directly into better performance on logic problems.
That's a fascinating takeaway. Brevity as a form of reasoning. So let's talk results. You mentioned it beat the teacher.
It did. They used DeepSeek R1 0528, a huge 671 billion parameter model, to generate the training data.
So that's the teacher.
That's the teacher. And the Nemotron-Cascade 14B model, a fraction of the size, outperformed it on major coding benchmarks like LiveCodeBench.
And I saw the 14B thinking model even grabbed a silver medal at the IOI 2025.
The International Olympiad in Informatics, yeah, which is a huge deal.
So how did it pull that off?
They used a strategy called test time scaling. Instead of one shot, it generates multiple solutions and then picks the best one. But for me, the 8B unified model is actually the bigger breakthrough for everyday developers.
Because of that toggle feature, right?
Exactly. Usually you have to choose. Do you load the heavy reasoning model that takes ages or the fast chat model?
And you can't have both.
Well, the Nemotron 8B unified does both. You just add a think flag to your prompt for deep reasoning or nothing for a quick answer. It switches modes instantly with no performance hit.
Okay, that brings us to their final exam. Software engineering. This isn't just writing a function, this is fixing real bugs in a code base. How did they tackle that without some massive, complex agent?
They went agentless. Instead of a complicated loop of planning, using tools, reflecting, they just simplified the task.
Into what?
3 steps. Localize the bug, repair the code, and then validate the patch. But the really clever bit was how they trained the repair model.
Because grading code is slow. You have to run the tests.
Right. It's a huge bottleneck. So they built what they call an execution-free reward model.
Execution-free?
They trained a separate, smaller model to just check for semantic similarity. It looks at the AI's proposed fix and compares it to a known good patch.
So they essentially taught an AI to vibe check the code instead of running the compiler.
That's a great way to put it, yeah. It allowed them to scale up training massively, because they weren't waiting around for test suites to run. And it works. It's state-of-the-art for a model of its size.
It really seems the big lesson here is that maybe we've been too focused on size, on scale.
When we should have been focusing on the lesson plan.
Exactly. By structuring the learning logically, by teaching it to communicate clearly before asking it to code, they've shown you don't need a supercomputer to be best in class.
It's smarter training, not just bigger models.
And here's a thought to leave you with. This study proved that removing verbosity, just cutting out the fluff, made an AI's raw logic better. If that's true for a machine, How much is over-explaining and rambling hurting our own human problem solving?
Something to think about.
Thanks for listening to this deep dive.